the ACT math portion. I strongly recommend that you have your graphing calculators today. We're gonna go through algebra, geometry, all of the above. So we'll go into it. So as you can see, today we're doing math. First, I'm gonna talk about the timing strategies, how much you should give for each, because you're gonna see that although you have a whole hour to the section, you do have 60 questions, which it doesn't sound bad because the first 20 questions are going to be super easy, but then you're going to get and progress and it's going to become more difficult and more difficult. So that's why I recommend that for the first 20 questions, you do 30 seconds each. Like you shouldn't go over 30 seconds to the first 20. Then the next 20, you do a minute. And in the last 20 minutes, you leave a minute and 30 seconds. Another word of advice for these, if by like the first 10 seconds of you reading it, you don't understand what it's saying, keep on like moving on and just start it and go to it in the end, because you have so much ahead of you that stopping in one, it's not worth it, really. So today we're going to be going over important equations and important questions that always show up commonly on the test. If you want to scan this QR code, it is a Quizlet of 58 different equations that you might encounter on the test. I literally searched it up like 5 seconds and it popped up, and it was full of everything from coefficients, binomials, and everything that you might find on the test. So I strongly recommend that when you get the chance, you either scan it, or when I put the YouTube video or the email, I'll link it in. But let me just go into this. This is basically the math that you're tested on. In fact, the first 5 are the ones that the ACT acknowledges. So they acknowledge that you're going to be tested on number and quantity, algebra, functions, geometry, and statistics. Very basic stuff at first, but then they can progress. And what they might do is they might get 2 different branches of math and put it together in one question. And then these last 3, they're not like they're separate unit, because they're found, like for example, matrix and vectors are technically found in number quantities, but you typically don't see them when you search up number quantity questions. It's very important because this will always show up. It's a hands down, every time I've personally taken it, I have seen the matrix question, whether it be a practice test, there's always a matrix question. And then vectors are also, they very much show up. And I know that some people freak out a little bit because it's a physics concept, but honestly, I think it's going to be very easy once you get it. And finally, time questions, like, oh, they were running 1 mile per hour, 2 miles per hour. What's the distance that they traveled and stuff like that. Any questions? Is there any specific topic that y'all are more interested in covering? If you want, you can type it in the chat so I know in the future which one you have more trouble with. Personally, when I took it for the first time, I flunked my stats and probability because I'm a calculus kid. But as I progressed, stats has become one of the more easier ones. Geometry as well. Yeah, geometry can be difficult, especially since they like giving geometry as one of the more difficult questions. And we have some geometry questions today, so we'll go over it. And algebra too. We're gonna be going over everything today. So I'm gonna first start with numbers and quantity. So we got number systems. Number systems, it's very basic. It's addition, multiplication, division. It's like basic math. But then we have the exponents and then the vectors and matrices. And actually so first off, let me just explain the fractional exponents part, because this is always shown on the ACT, SAT. And a lot of people, what they do is they start plugging in the numbers, and then you get like this huge decimal, and then people are like, oh, let me just figure it out. But if you know what the fraction means, then you can quickly do the math on your own. So let me show you this. You see this over here. Let me just give an example. If you have 2 over 1/3, right? That is the same thing as saying 2 cubed, okay? That's the same thing, and it's going to help you a lot. We actually have a question coming up that is this. But then you see this one over here where you have an m. Let's just say it was 2 to the power of 2/3. It'll be the same thing as saying 2 cubed to the power of 2. You could technically leave the 2 outside, or what I prefer doing this first, so I can just have it like this. Any questions on this method of writing the numbers? No questions?
No.
Beautiful. Thank you, Dani. Okay, so I'm going to give you a question here to just do it. I'll be giving you, it shouldn't take you more than 30 seconds, honestly, but I'm going to give you a minute to do it, okay? I'll put a timer. You can start in 3, 2, 1. I'm going to explain this quickly, because I need to go back, actually. For this, a little word of advice, because I see what you did the opposite, like they're not flipped, because when you have a negative number as the exponent, what you take is the reciprocal. Okay, so what's gonna happen if I have a negative exponent over here and it applies to everything? First thing I'm going to do, I'm going to take the reciprocal of the fraction. Does anyone know what the reciprocal of this fraction is? Reciprocal is just it flipped. So it's 64 over 27, okay? And then the 2/3 stays positive now. Basically, once you flip it, the exponents become positive. And now you might be wondering, why in the world does it have 2/3? When you have it like this, you just distribute the exponents to each number, okay? So this is the same thing as saying right? And then if you just plug it into your calculator, 16 over 9. Okay? Any questions? We good?
Yes.
Beautiful. Okay, there. Beautiful. Okay, next up, we're going to go over matrices. Does anyone have any questions about how fractions work on the exponential? Like when it has a negative exponent? Are we all good with what a reciprocal is? Yes? Okay, beautiful. Okay, next we're going to go into matrices. There's different ways to go into matrices. Matrices have their rules, but then also if you have this bad boy right here, this thing can save you a lot of time. As you can see, I put here, if you go to your graphing calculator, if you have it on you, you can go to second, and then you can press the little matrix. You see the little matrix over there? And then it's going to give you, let me see. I can't really show my screen right now, but you're going to see where it goes names, math, and edit. You can go to edit, and then you can edit the matrices to your likings, and then you can just plug it in. And then once you plug it in, it'll give you your answer. For these, though, before you plug in your answer, you can save a little bit of time. Let's just say on the test, because it is possible. On the test, they only give you this, right? They say to solve this. Forget about this part of subtracting it. Does anyone know what we're supposed to do here? If you want to put it in the chat. If anything, don't worry, I can explain it. But yes, you are right. Yes, Amanda. So you multiply each. So you get 9, -12, 6, and 18. And that's your answer. Okay? So you could technically go all the way into your matrix and put it in the calculator and solve, but for things like this, you can just multiply everything and you can do it in less than 30 seconds. Okay. So now that we explained matrices, I do have a practice problem for matrices. I'll give you a minute to do it, but once you practice matrices more, you'll be able to do it in 30 seconds. You can start now. And yes, it is D. It's 2. Okay? So good job to the person who got it. Okay. I would just say that this is easy to just plug it into your calculator. If you need still practice on how to put it into your calculator, just text me privately and I'll send you like a video through WhatsApp or DMs on Instagram. But you just plug in the columns on your calculator and then it'll spit out the answer. Okay? So now we're gonna move on to vectors, which I honestly think is pretty cool because it looks complicated, but it really isn't. So for vectors, when you're adding them and they're going in the same direction, you're just propelling yourself even farther. So for example, 12 plus 20 will equal 30. But then if you're going in opposite directions, if you're going up and then this one's going down, you subtract them from each other. And in these, at first it's like, how can I find the distance of the vectors when they're going in completely different directions and they're not like on the same plane? Because normally vectors are seen in the x and y axes. When it comes like this, you can technically picture it, as you can see, it's kind of a spoiler over here. You can picture it like this, and this is what you need to solve for. And does anyone know what theorem that is? If this is a right angle.
Pythagorean theorem.
Yes, ma'am. That is a Pythagorean theorem. So all you gotta do is solve a squared plus b squared equals c squared. Okay? But then on the Pythagorean theorem, okay, there we go. On the vectors, there's sometimes that they just give you points. Okay? So when it comes to points, it's very simple. If they're telling you to add u and v, you're just going to add the x values and then add the y values. And to tell you to subtract the vectors, just subtract the x values and subtract the y values. Any questions on vectors?
No.
Beautiful. Okay. Now there is a question on vectors. This should take you 30 seconds really, so I'm going to put 30 seconds on the clock. You can start now. Okay, time's up. Does anyone have an answer? Okay, I can explain it. So when we come to vectors, let's see here. The vector I, well, vector I represents east, right? So you know how we have never eat soggy waffles. And it's saying that I represents east. I like to think of it as it's now representing the x-axis. And then J is representing north, which is kind of like the y-axis. But in this girl, she's walking in the other direction. She's going south, right? So she's going this way. And on what vector is she walking on? Is she walking on the vector that's going like this? Or is she walking on the vector that's going like this? By the way, this is vector J.
Up and down.
Yeah, so she's walking up and down. So she's on vector J. So since she's on vector J, but instead of going positive, she's going negative, the answer is going to be negative 12J. Okay? Thumbs up?
That makes a lot of sense.
Thank you. You want to try? I may just give you another example. Let me just make up another example. Okay. Let's just say instead she was walking, or she was jogging really, west 12 miles per hour. What would be your answer? You can put it in the chat. Yes, it'll be A. So she's walking in the I vector in the negative direction. So best word of advice for vectors, just think of it as the x and y axis. Okay, they're just lines. Okay, moving on to this question. This question here is very much algebra based. It's a lot of logic, but once you've try it the first time, you might get it wrong. I got it wrong my first time, but this, I guarantee you, will show up. So if you want to take a hack at it, I'm going to give you a minute. I'm going to give you a little like nudge in the right direction. A week is 7 days, right? And if it let's just say it would land on a Tuesday, the number has to be divisible by 7. Okay? Try to see if 200 is divisible by 7. And if it's not divisible by 7, try to use logical reasoning to see what day would come next that would make 200 divisible. Okay? I'm going to give you a minute to do that one.
Hello, let me quickly explain this one that we did on Zoom. I know that I kind of rushed through it because of the time, but let me just explain it. So given today is Tuesday, what day of the week was it 200 days ago? Let's just say that they give you a number that's completely divisible by 7, right? If they did, then bingo, it's a Tuesday, but it's not, because it's not divisible by 7 perfectly. So what you're gonna have to do is you're gonna have to go backwards in time. So you're gonna have to go into different days to see, well, if I know that the number, if I divide it by 7 is going to be a Tuesday, let me try to find a number that's divisible by 7 to know that that day was a Tuesday. So I start going backwards. No, let me go 2 days backwards. Not really. 3 days backwards? No, but then I go to my 4th day backwards and I realize, there we go. The 196th day was a Tuesday. So, how many days was it backwards from 200? 4. So we're just going to get into a calendar and we're going to go 4 days backward. Monday, Sunday, Saturday, Friday.
Okay. All right, now I'm going to move on to the algebra equations. So these 2 questions are going to show up a lot. There's going to be questions on the ACT where they might ask you to simplify these questions. So just to make sure you can expand them, they can expand like this, and vice versa. They might ask you to simplify them. And then they might ask you slope. Everyone knows slope. And then they can ask you some substitution questions. So don't fret right now, but I'm going to give you an algebra bell ringer, which should take you 4 minutes to do, and then we'll talk about them, okay? Okay, just to make sure, do we all have our 4 answers? Thumbs up? Okay. So I'm going to show them. So these are the answers. We're kind of a little bit short, not short on time, but is there any of these 4 that you didn't get that you want me to explain that were a little bit difficult? You can type the number in the chat. The second one? Okay. Let me just double check. Okay. Well, for this one, what is the slope of the line? So this is slope intercept, y2 minus y1, x2 minus x1. So then you get your y2, which is your -3, and then this -7, and then you get your x2, 3 plus 2. Yeah. Any questions on that? You see, it works up here. Again? Okay, beautiful.